Right, so today we're just going to continue with the kind of series of videos. So far we've done independent test, which is the parametric version, and the man with new, which is the non-parametric. We've also done the dependent t-test, and this is the kind of the second kind of phase of that, so the non-parametric equivalent, which is the Wilcoxon rank test. It kind of works the same way as the man we knew, in the sense that it basically ranks all the values on the scale. So small values will get like a 1 and large values will get like a 10. And obviously that tells you that if you've got a lot of large values, you'll have overall a higher rank. So yeah, dependence, so something that's linked to each other. So you basically do the same thing to the same subjects twice. So if we look here, the researcher is interested to see if caffeine gels cause a difference in how hard the participants find the 30-second sprint on an exercise bike. She measured the ratings of perceived exertion RPE on a Borg scale of 6 to 20. So again, as we can see here, we're asked for a difference. So we know we're looking at some sort of t-test. Participants, we're testing the same ones twice, once with the caffeine gel and once without, because we're trying to see if they do cause a difference. On how because we can't ask two different people to rate how they perceived it, as obviously everybody experiences things differently. So therefore, in this experiment, they chose the same people. What is interesting though is that we're using a scale, so that is a type of ordinal data. So if we think about the other types of data, we've got nominal, which is something that is like a grouping variable. So like we did cats and dogs in the life satisfaction video, or something like sex. It's either one or the other. You can't have an in between or anything like that. Then we've got continuous, so that's like your height, which can be any number. So we say we're 1.70 m, but you can easily be 1.69.9999999 because it's continuous, right? We can have it at anything. Same with shoe size. The last type of data is ordinal data. So that's something that has a scale. So for example, how much you like something. If you like biscuits, 5 on a scale from 1 to 5, that's ordinal data. And the thing is with ordinal data in statistics, is that if we see it, we jump straight away to the non-parametric test. So what does that mean? So if we said here we know we're doing a test of difference, and we knew that the participants were tested both before and after being received the gel, we kind of think about, okay, we're going to do a t-test. But if then you read that they applied a Borg scale, you would straight away ignore, you don't need to check for normality, and you can jump straight to the non-parametric, the Wilcoxon. And this is the same with the independent t-test. If this was used on two different subjects, so males and females, for example, or two different males, and you saw that they were again rating on a scale, then you would straight away go to the man with new. So yeah, let's go into Jamovi and have a look how we would get this data up. So here we've got, so we don't need to worry, this is gum. This is a different question. So here we have the scale. We've got the caffeine gel and the placebo gel. So that's basically, they probably took this first, went on the bike, and after they took this, applied the gel and went on the bike to do the experiment again. So if we go into, because we know this is a paired test, if we go straight into it. Okay, so we've got this here. So this is exactly the same as our test of independence. We do a caffeine or whichever way around, but just make sure you read the question and know which one you're testing. So in this case, we're doing gel. So as you can see here, for dependent t-test, we don't need to worry about homogeneity. We just need to worry about normality. Okay, so we've got it here. So as you can see, what we normally would do is we check for this normality, and if this value was above this p-value was above 0.05, we would be like, okay, let's just carry on with our t-test. But because this is on a Borg scale and it's ordinal data, we need to ignore this, and we'll jump straight into the Wilcoxon rank. So that's one of the kind of exceptions to checking the normality if you have ordinal data, so watch out for that. Okay, so we've got our Wilcoxon W, and that's our statistics. So that's kind of the equivalent of the U, but for dependent tests. And we've got a p-value. For non-parametric, you don't need to really worry about the mean difference and confidence interval and like reporting that. It's not really that important, but yeah, the effect size is always nice to add. But as you can see here, in this case, our data is non-significant because this p-value is above 0.05. And also because this is non-parametric data, again, we report the median and something like the variance or the range, something like that. So now we have pretty much everything that we need to report our data. The only thing, again, if you want to get more of these descriptives, you can go to exploration and descriptives here. Yeah, so you go into descriptives, place in your gel things, cross out these n and missing because you don't really need them, and then anything you want. So you got your range, variance, and then just your median. Cool, so we've got that here. So we've got our median, variance, and range, so whatever you want to report. So how I did it, so RPE, measured on this Borg scale, was not significantly different in the caffeine gel condition, with a median of 30 and a variance of 4, then the placebo condition with a median of 12, and then again you don't need to write the variance because you written it here, so 5. So then we have our W of 120, a p-value, which tells us it's non-significant, and then the R value. That's basically it for that. Just it's important to remember that, so you normally follow kind of this pattern where you acknowledge what tests it is, or what kind of test you're doing. Are you doing a test of difference? Are you doing a correlation, a chi-squared, or anything? And then you find out if these, and then you kind of follow different paths depending on the test, right? So you're trying to see if these participants are the same people being tested or different. But as important, especially for these tests of difference, you need to look if the data is ordinal. The same will go for correlation when we get onto that if the data used is ordinal, we'll go to the non-parametric equivalent. Just make sure for that, and it's a good way, if you spot that, to not waste your time with the normality and the assumptions and just jump straight to the non-parametric view. Because the reason why we do this is because when we do parametric and you're trying to see the mean difference, on this Borg scale, you can either score between 6 and 20, right? You can't score a 6.5, for example. It has to be whole numbers. So therefore, the mean wouldn't really give us anything, because even if the mean was 12.5, that doesn't tell us much because we can't score 12.5 on this scale, right? So that's why it's much more convenient to report the median, because that's always going to be a whole number, and the median tells us the middle value that people reported, and it gives us much more detail on this difference. So yeah, I hope you enjoyed this little video on the Wilcoxon rank test, and we'll see you next time on probably some correlations. Yeah, thank you, give a like, subscribe, and have a good day.